Left off on determining when there's no solutions, when there's one solution, or when there's infinitely many. And let's just do a recap on that. If the equation is, whenever you solve it, it always ends up being false. So for example, 6 is equal to 7, then there are 0 solutions. If whenever you solve the equation there is one solution, so you get down to something like x is equal to 2, then there is one solution. And whenever you come down and you end up with something that's always true, so for example, 3 is equal to 3, then there are infinitely many. Note that this does not have a variable in it, and this does not have a variable in it, which is how it's always either false or true. So let's work some examples from what we've seen before, and using properties of equality and such, and we can see how many solutions there are. Generally, you're going to find that there's one solution. Okay, let's do 8 minus 2 times 3y plus 5 is equal to 0. So first, let's rewrite this. 2 is minus 2 times is going to be the same thing as plus negative 2 times 3y plus 5. And now we can use the distributive property. We get negative 2 times 3y plus negative 2 times 5. Negative 2 times 3y is going to give us negative 6y. And then negative 2 times 5 is going to give us negative 10. Now, note by the commutativity of addition, we can swap these two and say we have 8 plus negative 10 plus negative 6y, 0. 8 plus negative 10 is negative 2. And then plus negative 6y is the same thing as minus 6y, 0. Using the additive property of addition, we're going to, the additive property of equations, we're going to add 2 to both sides. And then using the associativity, we can, we have to be careful here, but we can go ahead and use the fact that this resolves to the identity, which is 0 minus 6y is 2. And so we're left with negative 6y is 2. Let's see if we can finish it out in this little box over here. So if negative 6y is 2, we can multiply, we can use the multiplicative property of equality and use the inverses to multiply by negative 1/6 times negative 6. Y is negative 1/6 times 2. Well, we have a negative times a negative, that's a positive. And we have 1/6 times 6, that's going to be 1, right? We have basically the reciprocal times itself. The reciprocal times the number. So we have something that resolves to 1, the identity, times y. And then negative 2/6 is going to be negative 1/3. Otherwise, otherwise known as y is 1/3. And we can go back and plug that in. We get 3 times negative 1/3, and we get negative 1. Negative 1 plus 5 is going to give us 4. 4 times 2 is 8, and then 8 minus 8 is 0. So it works. Let's do another problem. We're going to do 2/3 x is equal to 18. This one's easy. If we multiply both sides by the reciprocal, which is 3/2, using the multiplicative property or the multiplication property of equalities, we notice that we have those two together, anything multiplied by its reciprocal, like we have here, is going to resolve to the identity. So we get 1x is equal to, we have 3 halves times 18, which is going to be 3 times 9, which is 27. So x is 27. Let's look at x plus 1/3 is equal to 1/6 x minus 1/2. We want to get all of the x's by itself on one side and everything else on the other, right? Because that's how we're going to solve it. So if we add negative 1/6 x to both sides, whoops, negative 1/6 x, nope, go away, plus 1/6 x. This resolves to the identity. So on the left side, we have 1x minus 1/6 x. So we have 6/6 minus 1/6. Let's go ahead and do it. We have negative 1/6 x plus 6/6 x, right? Because it's 1x and then 1 is 6/6. Maybe we should split those out into separate steps. 1x plus 1/3, 0 minus 1/2. So then we have negative 1/6 x plus, what 1, the equivalent fraction for 1 is 6/6x, plus 1/3 is going to be negative 1/2. Now if we take these two, we have negative 1/6 plus 6/6. If we remember how to do fractions, that would be negative 1 plus 6/6 times x plus 1/3, negative 1/2. That gives us 5/6 x plus 1/3 is going to be negative 1/2. So now if we take both sides and add negative 1/3 to both sides, maybe we can squeeze it in up here. Then right here, this is going to resolve to the identity, which is 0. So we get 5/6 x plus 0 is equal to, now we need to find equivalent fractions for these. Let me do it in blue. So negative 1/2 is negative 3/6, right? Because the least common denominator here is going to be 6. So we need to multiply the bottom by 3 and the top by 3 to get negative 3/6, plus negative 2/6. So over here we're left with, whenever we add those together, we keep the denominator, negative 3 plus negative 2. So we get 5/6 x is equal to negative 5/6. Finally, we can multiply both sides by 6/5, the reciprocal, and we get 1x over here, right, because we have something times its reciprocal, which is going to resolve to the identity. We get 1x is equal to negative 1. So x is negative 1. If we go back and plug that in, we have negative 1 plus 1/3, which is going to be negative 2/3, is equal to negative 1/6 minus 1/2. Remember, 1/2 is the same thing as 3/6. So negative 1, negative 1/6 minus 1/2. Oh, yes, of course. Sorry. Negative 1 minus 3 is going to be negative 4. And then keep the denominator. negative 2/3 is in fact equal to negative 4/6, right? Because that reduces to negative 2/3. So all is well. We have indeed found one solution. Let's look at another. This one's going to involve absolute values. X plus 5 going to be 15. So the absolute value of x plus 5 is 15. Absolute values are a little more difficult to solve because we have the case where it could be any number of values. So what we have to do is, to get x by itself, we're going to have to get x by itself, we're going to have to take the equality, or the absolute value, and say that we can remove the absolute value, but we have to solve two different equations. So the first equation is x plus 5 is 15. So just like we would see here, just removing the absolute value bars, what I'll do is I'll split this page. So remove the absolute value bars and solve it. You get x plus 5 is 15. That's pretty easy. We take both sides, add negative 5. On the left, this resolves the identity, which is 0. Oops. X plus 0. 15 plus negative 5 is 10. So we get x is 10. There's one solution. The other is if we make it negative. So negative, and you have to make the entire absolute value thing negative. Use the fact that we actually have a negative 1 out front to distribute. So we get negative 1 times x plus negative 1 times 5, 15. We're left with negative x minus 5 is 15. We can take both sides and add 5. So we're left with negative x is equal to 15 plus 5 is 20. And this resolves the identity, right? I just didn't write that there. That's 0. The problem is we don't want to know what negative x is. We want to know what positive x is. So we need to multiply both sides by negative 1. And so negative 1 times negative x is just x. And then negative 1 times 20 is negative 20. So here we have the case of actually having two solutions. And that's because this equation isn't linear. It looks linear, right? It looks like we have just a linear bit, but the absolute values are going to make it nonlinear. So what the equation of this might look like is the absolute value of x plus 5 is 15. Really, the absolute value of x plus 5 is going to look something like that. And then 15 is just going to be a line like this. And so you can see we have two solutions. This one would be where x is 10. This one would be where x is negative 20. You don't have to worry about graphing these things yet. I just want to show you that because this can't be negative, typically it would keep going down like this if it was a line. But the absolute value has to be positive, so you have to flip it up above the x-axis. And that's where that line comes from. And so it's able to cross it twice. Okay, so we have two solutions here. Next, let's take a look at 1 minus 3 times the absolute value of 5x minus 1. Say that's negative 17. So the first thing I think we want to do is if you remember solving these things whenever I mentioned, I think at the beginning of the semester, kind of want to work PEMDAS backwards. So the first thing I see here is we have something added on. So let's move it over to the other side. Added on to something where x is. So let's move it to the other side. And the way we do that is by adding negative 1 to both sides. Minus 3 times 5x minus 1 is going to be negative 1 plus negative 17. And note that this is a 1 and not an absolute value. And these are the absolute values here. So 1 plus negative 1, identity, which is 0. So we're left with negative 3. I'll put the 0 there. 0 minus 3 times the absolute value of 5x minus 1. Negative 1 and negative 17 is negative 18. So here we have negative 3 x minus 1 is negative 18. We can multiply both sides by the reciprocal of negative 3, which is negative 1/3. Left side, using the associativity properties, we can group those two together. That resolves to the identity, which is 1, times the absolute value of 5x minus 1. And just because we're familiar with this being 1 out front already, I'm just going to go ahead and get rid of it, since it's kind of understood to be there. And then negative 1/3 times negative 18. Well, negative times a negative is a positive, so you know it's going to be a positive number. And 18 divided by 3 is 6. All right, so now we have this. Let's go to the next page and solve it. Absolute value of 5x minus 1 is 6. So we have two cases. We have the positive case and the negative case. So if the absolute value is positive, then we have 5x. We're just going to drop the absolute value sign and solve it. So add 1 to both sides. Those two go to 0. Multiply both sides by 1/5. And we get that x is 7/5. That's as reduced as that's going to get, otherwise known as 1 2/5. On the negative side, we have to make the entire expression that's in the absolute values negative. And remember that that negative is a negative 1. So we distribute, we get negative 1 times 5x plus negative 1 times negative 1 is 6. Simplify, we get negative 5x plus 1 is 6. Well, negative 5x plus 1, if we add a negative 1 to both sides, on the left side we get negative 5x. That goes to 0. 6 plus negative 1 is 5. Multiply both sides by the reciprocal of what's on x, and we get negative 1/5. Negative 5x is negative 1/5 times 5. We get x is negative 1. So there are two solutions there. If we go back and plug it in, let's start with 7/5. 5 times 7/5 is 7. 7 minus 1 is going to give us 6. 6 times 3 is 18. 1 minus 18 is, in fact, negative 17. Now let's try negative 1. 5 times negative 1 is going to give us negative 5. Minus 1 is going to give us negative 6. The absolute value of negative 6 is 6. So 3 times 6 is going to be 18. And 1 minus 18 is negative 17. So both of these work. I believe that's where we're going to end it for today. That has been how to solve linear equations and how we're going to use properties of equality. Next time, we're going to be using formulas to solve word problems, which is just going to put like an extra layer on top of this.